Ignition sequence starts.
Good morning. You're looking at Mission Control Houston, where the International Space Station Flight Control Team members are on console, keeping track of all space station systems and working with the Expedition 63 crew members, closing in on the end of a busy work week. Commander Chris Cassidy and flight engineers Anatoly Ivanishin and Ivan Wagner have been getting themselves and their vehicle ready for the arrival of a new Japanese cargo ship carrying 4 tons of supplies, which is now on its way for a Monday morning rendezvous.
Welcome to Space to Ground. I'm Kayla LaFrance. With the count up to 20 years aboard the International Space Station underway, the station prepares for upcoming visitors and historic flights.
And we have liftoff.
On Wednesday, the HTV-9 cargo vehicle launched to the orbiting laboratory. HTV-9 is the final flight for the current JAXA cargo vehicle design. The vehicle is carrying over 6 tons of cargo and payloads, including NASA's final express rack to the station. These payload and science racks support cutting-edge science in space and are charting a course for human missions into the solar system. The crew will welcome the HTV-9 when they capture the cargo craft with the Canadarm2 robotic arm on Monday at about 6:45 a.m. Eastern. NASA astronauts Doug Hurley and Bob Behnken arrived at Kennedy Space Center in Florida ahead of their upcoming flight aboard the SpaceX Crew Dragon. The duo met with NASA Administrator Jim Bridenstine to share their thoughts on their historic flight next week atop the SpaceX Falcon 9 at Launch Complex 39A.
This will be the 5th time in American history when we have launched American astronauts on a brand new vehicle. And it's these gentlemen that are going to have the opportunity to pioneer once more for the United States of America in what is this new era in human spaceflight.
As graduates of military test pilot schools, if you gave us one thing that we could have put on our list of dream jobs that we would have gotten to have someday, it would have been to be aboard a new spacecraft, be conducting a test mission aboard that spacecraft, and Doug and I get that chance to do it.
It's an incredible time for NASA, the space program. Once again, launching U.S. crews from Florida, and hopefully just a week from about right now, which is incredible.
The week's coverage of the DM2 mission will begin on Monday with a pre-launch briefing from the Kennedy Space Center. The NASA Administrator will hold a countdown clock briefing from Kennedy on Tuesday, the day before launch. And launch day coverage will begin at 12:15 p.m. Eastern on Wednesday, with liftoff set at 4:33 p.m. NASA TV will then have wall-to-wall coverage of the DM2 mission from launch to docking, with the arrival of Bob and Doug to the International Space Station at 11:39 a.m. Eastern on Thursday. Keep sending in your questions using the hashtag AskNASA. We'll see you next time.
NASA TV and NASA.gov will provide live coverage of the arrival of the HTV-9 cargo vehicle at the station, starting at 5:45 Houston time this coming Monday morning, and then be back at 8:30 a.m. for live coverage of final installation of the ship onto the station's Harmony module. And be sure to join us this coming Wednesday for live coverage of the first launch of astronauts aboard a SpaceX Crew Dragon spacecraft. We start at 11:15 a.m. Central, right through launch at 3:33 p.m., straight on through to the arrival of Doug Hurley and Bob Behnken at the station on Thursday morning. The DM2 mission will be the first in NASA's Commercial Crew program to carry astronauts to space. Here are 2 more of our Commercial Crew astronauts to guide us through the program that will resume the launch of astronauts to space from right here in the USA.
NASA's Commercial Crew program is ready for launch.
Did you know the last time we launched astronauts from America was in 2011?
NASA is working with companies Boeing and SpaceX to take astronauts to the International Space Station from America once again. Let's look at how this will happen.
Look at the spacecraft on top of the rocket. This is where humans will be sitting. The astronauts will be buckled into a spacecraft, stacked on top of the rocket as it is launched into space. The rocket holds all of the fuel needed to get to space.
It takes a lot of energy to lift the rocket off the ground, with gravity constantly pulling it down, which is why most of the rocket is filled with fuel. During the rocket's climb to space, it will increase in speed, which means its energy will also increase. Once the rocket has made it past Earth's atmosphere, the engine will finally cut off. The rocket and the spacecraft will separate, and the astronauts will make their way toward the station, where they will be working on science experiments and engineering projects.
What do you think will happen when the spacecraft travels back to Earth?
Boeing has made the Starliner CST-100 to keep astronauts safe as they travel to and from the station. It's designed to touch down safely on land in the western United States. The Starliner has parachutes it will use as it prepares for landing, but will also have large airbags expanding under the spacecraft to cushion the landing for the astronauts before stopping completely.
SpaceX's Crew Dragon was also created to send astronauts to and from the space station. As the spacecraft comes back to Earth, the outside will experience temperatures over 3,000 degrees Fahrenheit. The Crew Dragon has been designed to keep the astronauts inside comfortable during their ride home to Earth. Once they are back in the atmosphere, the spacecraft will release 4 main parachutes to slow down the speed and energy of the vehicle before it splashes down in the Atlantic Ocean or Gulf of Mexico. These spacecraft are exciting sneak peeks at the future of space travel.
And NASA's Commercial Crew Program.
Want to know more about space travel? Check out this website for more information.
When they float on board the International Space Station next week, the Crew Dragon astronauts will become members of Expedition 63 and have a part to play in the scientific research in the station's laboratories. Some of those experiments take advantage of the weightless environment. For example, an experiment involving a device about the size of a thumb drive containing human cells in a 3D matrix, which may help scientists learn how the cells respond to stresses, drugs, and genetic changes. The devices are known as tissue chips. International Space Station crew members who support the research mission on the station get a large share of their training on the science payloads right here at the Johnson Space Center in Houston. In this segment of the new NASA Explorers series, we go to class with the NASA astronauts as they go through training for a trip to the station.
Hi, I'm Terry Virts, and I want to talk about floating in space. One of the first things that you need to realize when you get into space is that even though you feel like you're falling, you're not. You can let go and you float. It's not a problem. It's something you really have to train your brain to think about. Another thing that you need to learn when you first get into space is how little force is required to move you. And another cool thing is you could be on the ceiling. It makes it very easy when you're working. You have to get some work done up here. You just go up on the ceiling and get your work done.
Our team of scientists is busy getting their experiment ready for launch. At the same time, NASA is preparing the space scientists who will operate the experiment aboard the International Space Station.
So as astronauts on board the space station, we are the hands and eyes of the researcher. They are telling us how best to do the science, but it's up to us to make sure that science runs correctly.
Astronauts train all over the world, including at NASA's Johnson Space Center in Houston, Texas. Here, they learn not just how to live in space, but also how to conduct science in microgravity.
So many folks ask, how much training did you do before launching to the space station? And the answer is many years. So we train in a lot of big areas. Number one is systems on board the ISS, robotics, how to do spacewalks, and actually science itself. Now, we don't learn about a lot of the science experiments we're doing until we get up there, but what they are teaching us is scientific techniques.
The techniques astronauts learn range from using tools like pipettes and microscopes in microgravity to operating scientific hardware aboard the space station. For example, we study combustion aboard the station because it behaves differently in microgravity. You wouldn't want fire to get free inside your home in space, though, so we've created special facilities to contain it. If it looks complicated, it's because it is. And it's just one of the pieces of equipment astronauts must master before they go to the space station.
Hi, I'm Tracy Neff, and this is Sharon Ranke, and we're in PDL2 right now, and we're down here at JSC to do the fluids and combustion facility training for the combustion integrated rack and the fluids integrated rack.
So basically, PDL2 is a mock-up of the US lab. Since 2008, we've been coming down and training all of the crew members who will do payloads on the space station. We've been training cosmonauts as well.
How many crew do you think you've trained at this point?
Probably 50, probably over 50 crew members we've trained.
Today, Tracy and Sharon are back at work with a former student, NASA astronaut Mike Fink. This isn't Mike's first rodeo with the station, or this equipment for that matter.
So back in 2008 and 2009, we were aboard the International Space Station when a space shuttle, STS-126, Chris Ferguson and crew, dropped off a whole big bunch of packages. And we carefully and slowly put it all together. But when it was all done, we had a brand new, ready, fresh out of the box combustion integration rack. And since then, our friends at Glenn Research Center here at NASA, we've been able to get some fantastic science about how things burn in space. Without gravity, without convection, things burn. And by understanding that better, we were able to make more fuel-efficient engines and things here on planet Earth, helping save our energy.
So you can see it in the video. All the hoses are within the ring, and so they all fit in nicely, so they shouldn't interfere with us.
Sounds great and looks great. Thank you.
Well, a lot had changed in 11 years since he was up there. So he did get most of the information again, and it was a new experiment, so he hadn't seen that either. He did great. He's a quick learner. It's great to work with, very methodical, and good humor, which is always, we like to have fun when we're training.
But the lab camera will be showing,
we have
and
the camera.
I will be like looking, and I'm gonna go slowly, and that would be your chance to say no.
Yes, we are watching you. Yes, and help you whenever we can.
This isn't the last time Tracy and Sharon will work with Mike. When he launches to the station and works on combustion projects in space, they'll watch over his shoulder through a camera broadcasting to Glenn Research Center in Cleveland, Ohio.
Christina, this is Sharon with an answer to your question. So they do want you to go ahead and install the cable tie.
Copy all. Thanks for having that down for me.
Anytime.
Being able to operate and maintain the space station while conducting crucial research could get overwhelming. Luckily, astronauts have strong support teams on the ground and often develop personal connections to the research.
I was so impressed at the different things we'd be working on, cancer or Parkinson's or even Alzheimer's disease. So as a physician, these meant a lot to me. These personally were very important experiments that we needed to do. But in all honesty, the entire crew, not just myself as the physician, were excited about working on these experiments. You get a little nervous at first as you begin to pipette or even utilize a microscope, which I hadn't used in years. But you quickly learn because you realize how important it is to the science, and the investigators and scientists running you through all these experiments were fantastic and just walked us through every step of the way.
Yeah, just keep us posted, but Drew and I are ready to continue ops. Good working with you guys today, and I'll see you soon.
We got here on a Thursday, and it's currently Sunday. We put in a big day yesterday filling up these wells with gel solution and getting ready for handover at 7:30 a.m. on Monday, ahead of launch on Tuesday afternoon.
One goal of the International Space Station is to help us learn what we need to know to support future space exploration, such as working out the systems of the new spaceships to support the human needs of the astronauts on long journeys to deep space. And that would include systems to provide clean water. In this installment of this demonstration video series, astronaut Drew Feustel discusses the water recovery system used to recycle crew wastewater for consumption.
Hi, I'm NASA astronaut Drew Feustel. Welcome to the International Space Station. On our station, our water recovery system is vital to our mission and our survival. Want to know why and how we recycle and filter our water? Let's go. We use water recovery and filtration because it is expensive to launch resupply missions, and the weight of the water is a problem as well. Think about the weight of a single bucket of water. Can you imagine the weight of water for a month's supply for 6 people on the International Space Station? What about the water for a year or more when we leave low Earth orbit for deeper space missions? That's a lot of water, and bringing it with us is not very efficient. On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat, along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day. The recycled water on the space station is sterile. There's no odor or bad taste. You've seen that water recycling is critical for long-duration missions, such as here on the space station, and will be for future trips to the Moon or Mars. Be sure to check out the activity connected to this video so you can learn more about water filtration. Thanks for learning with me, and I'll see you next time.
Spending a long mission looking out the windows of the International Space Station 250 miles above the Earth tends to make astronauts think a bit differently about their home planet. NASA astronaut Anne McClain has had that experience, and her perception of Earth was particularly changed by the experience of her first spacewalk.
On the day of the spacewalks, I remember I was over the hatch and they said to open the hatch, and so I opened it up and it was daytime. And the only thing I could look at was straight down at the Earth. And for 10 minutes, I just watched the Earth going by below me, and the only thing separating it was just my visor. And it was really incredible. And then we exited. They said go ahead and exit the space station. And I remember that was the first time I really got the sensation that I was being pulled by gravity. I was close to Earth, and I was very reliant on physics at that moment because I was holding on to the space station with one hand and my feet were dangling. I remember, not just through my visor, but looking down and you just see feet and then Earth, and you're holding on to the space station, and I mean, it was just incredible. Everything looked so large. But again, the most significant realization to me was looking out and realizing not how far I was from Earth, but how close I was to Earth and how connected I was to Earth, and how, we on the space station plus everybody on Earth and this planet is actually so small compared to this vastness of outer space. We have a small amount of gravity that keeps us in orbit around the Earth. And I was keenly aware that Earth was holding on to us. We were attached to Earth. What was amazing to me was looking the other direction and looking out into deep space, and it was infinite. And I realized, as I had one hand on the side of space station and we were both orbiting Earth, I felt I was very connected to Earth, like it was mine. There was some ownership there, and not my hometown or my city or what I was familiar with, but the entire Earth. I felt an ownership and a kindred spirit with every part of it. You do feel this closeness to every human on Earth. You have this really distinct recognition that every single person you will ever meet, you have more in common with than you do different, no matter what. Having been part of a program that takes so many people working together and doing the right thing, and you go, wow, look what we can do when we focus on that majority of us that are alike, that have a common dream. No matter where we grow up, everybody looks up at the sky and says, what else is out there?
One goal of the International Space Station is to help get us ready for future missions beyond Earth orbit, to the Moon and out into the solar system. The Artemis program is making progress preparing the hardware that will support those missions, from new testing on the Orion spacecraft to building the elements of the Space Launch System rocket and the systems on the ground to support those launches. Here's a quick look at what we've been up to lately. If you'd like to get another look at any of these stories, check us out on YouTube or Facebook. There are the addresses. And make sure to look around because there is lots of other cool stuff you can find about NASA and America's human spaceflight program. If you're going to be out on the internet anyway, you could also check out Houston, We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday, and today Gary Jordan previews the first flight of the SpaceX Crew Dragon with a joint interview with Doug Hurley and Bob Behnken, and a long talk with lead flight director Zeb Scoville with all the details of this historic mission. Go to nasa.gov/podcasts, where you'll find this week's episode, where you'll find all the previous episodes too. In fact, it's where you'll find the full library of all NASA podcasts, which are also available on Apple Podcasts, Google Podcasts, and SoundCloud.